This is Arvin Vora, founder of Vora Method. And in this video, I'm going to talk about how we make sure to help students avoid a one-to-one correspondence. First, let me explain what a one-to-one correspondence is. It basically is going to happen in math where essentially a student will memorize a separate formula for every possible situation. I'll give you an extreme example that I've seen a few times. Let's say that we have this circle here. And let's say I draw the diameter here and say the diameter is 6. Cool. If you understand how to even just use the basic formulas or what the words diameter and radius means, you'll just realize the radius is 3 and you'll use pi r squared. If you see a student doing something like this, if they've memorized a formula to get the area from the diameter, that is not a good sign. It's not like, oh, impressive, what a cool formula that you know. It's actually a terrible sign. It means that in their mind, they don't know what a diameter is. They don't know what radius is. They're not picturing this at all. They don't know. They don't care. Instead, what they're doing is memorizing a formula for every situation. And while they might actually have an impressive number of formulas memorized, under pressure, they're going to forget them all. You can't quickly access the right of 35,000 formulas under pressure. Generally speaking, students who are doing that are going to have decent quiz scores, terrible test scores, and just abominable exam scores. So allowing this to continue, you are not doing anybody any favors. So when you see something like this, that's what a one-to-one correspondence is. It basically means the student is memorizing one formula for every single circumstance. So how do we avoid that one-to-one correspondence? We basically do this by always making sure that we are teaching or allowing the students to understand the underlying concepts and never teaching the formulas. Now, if the student just discovers the formula on their own, that's great, because discovering that formula, and I mean discovering it, not like looking it up, discovering a formula like that really shows how deeply you understand something. Let's take a look at this. I've drawn this line segment and on theoretically on a set of coordinate on a coordinate plane, endpoints 1, 2 and 4, 7. And you might say, all right, you can use the distance formula, which you can. You can use the distance formula, and that's if you teach a student the distance formula, that's what they're going to know, and they're not going to have any. They're going to visualize as little as possible. They'll be plugging this stuff in just blindly and unthinkingly, and all those questions that you see in problems that you'll see in for example, the Pythagorean Advanced SAT worksheet, they're not going to be able to do because they've gotten into this habit of thinking formulaically. This, by the way, is one reason in our geometry program we save coordinate proofs till the end and usually don't even do it then. I mean, we want to make sure that people are thinking through based on the underlying ideas, not just plugging stuff into formulas. So how would we teach something like this? We'd want them to understand it in terms of the Pythagorean theorem. We'd want them to be able to see that this length over here, this length from 1 to 4 is 3. We'd want to see that this length over here is 5, and we want them to apply the Pythagorean theorem. Now you might say, well, the distance formula has a lot of applications. You use it to derive the equation of an ellipse or a hyperbola or whatever. And that's true, you do. And those are all great things. And if a student understands this thoroughly enough, and then we build on that and show that how you can use the distance formula to derive those equations, fantastic. But we don't want to start with the formula. We don't want to even allow or encourage the formulas in any way. You'll see that in a lot of the more difficult areas, probability, combinatorics, we actively avoid teaching the formula, but instead have the students figure it out. So in advanced combinatorics, we derive the geometric distribution, right? And you can just teach somebody the formula. It's not the formula so terribly hard. It's like, P to the n times Q to the, total number minus n, or however you want to P, and the first thing to the r and the other thing to the n minus r times the n choose k. You can write it like that. It's not wrong. But in doing that, all a student's doing is blindly applying a formula. They're not understanding where that comes from. In combinatorics, if you want to use the combinations or permutations formulas, it's not that those formulas are wrong. They're right. But we want students to understand where they're coming from and derive those formulas on their own. And in a lot of our worksheets, by the way, they actually, in the advanced combinatorics worksheet, students do derive that formula. We don't call it that formula because we don't want them thinking in formulas, but they do derive that formula. And later on, if they see it somewhere else, they'll be like, oh, I know where that comes from because I've derived it, 14 times on the worksheet and then 10,000 more times on the quizzes and pop quizzes and review questions. Avoiding that one-to-one correspondence, that is the most central thing that we can do over here. It's important to note that, a lot of us, people like me, I was a math major. I know some of you guys are math majors or econ majors, physics majors, computer science majors. We have an affinity for this stuff, right? This is intuitive for us. We like it. And so when you like a thing, sometimes it makes it actually harder to teach because you want to share so much, right? You want to say, here's a cool formula. Here's another cool shortcut. You want to do that. And what do we need to do? You just got to be disciplined. You got to say, as excited as I am to tell you this, I'm not going to tell you this until later. And later on, after they've dominated whatever test and like understand this super thoroughly, have a conversation about that. By all means, like right before they go off to Harvard, or even better, they turn down their admissions to Harvard to start a business. By all means, talk with them about it then. But don't talk about it in the early phases. You'll notice that there'll be situations in our curriculum where it seems like there's something glaring missing, like we forgot about it. And it's possible that there's something in there that we forgot about. But chances are we did not forget about it. We took it out on purpose. We didn't put it in there on purpose. So what should you do in an actual class setting? So let's say you're teaching class and you think that, oh my God, it looks like they missed something, because we make mistakes, especially with the curriculum changing so much. There is a chance of making a mistake. So what should you do in that circumstance? In that circumstance, if you suspect there's some information missing, let the lead instructor know. The lead instructor is going to be able to tell you if that's missing because it's an oversight, or it's missing intentionally because we don't want students to be doing that at all. One of the areas where you'll really see this is when students are learning long division. Long division is taught formulaically, obviously, and we're not going to expect kids to derive their own long division algorithms, but in those processes, we really want students to do that trial and error process. We want students to start to figure these things out on their own, to really become acquainted with this, to take the time that they need to take to really understand this. So you'll see this all over the place. If you think something's missing, just ask the lead instructor. And this is the part where it's the hardest. You're going to want to give hints. Everybody wants to give hints. Why? Because we're normal and helpful people, and you see somebody struggling, you want to help them out. And this is the really important part. In those circumstances, don't give any hints. Don't give any hints until long after the student has been begging for hints. And before you give a hint, check with your lead instructor. The lead instructors that have practice with this, we all know when you should give a hint. But don't give a hint. I mean, you don't give a hint in the first minute. You don't give a hint in the first 20 minutes. You don't give it a hint after a student has guessed it, made 3 guesses. You give a hint way into it, unless there are hints that are paired with that question, because those hints are designed specifically to not give too much information, to not give wrong information, and certainly to not create that one-to-one correspondence that we're trying to avoid.